Hey guys, welcome back to the channel. In this video, I'll be covering some examples and some steps of solving multi-step equations. In the last video, I forgot to mention that all the equations we're handling right now are linear equations. After we cover polynomials, we'll go into solving quadratics and more. So before we hop into the meat of the video, hit that red subscribe button and smash the like button for more content. So let's hop right into it. So in the last video, we covered basic some basic equations like x plus 3 is equal to 1, and we're solving them. Well, now, so if you guys remember, we undid the different operations. So if it was addition with subtraction, addition, multiplication, division, multiplication, simply. And what we do to one side, we do to the other. Well, essentially, we're going to be doing the same thing in this video, in this topic, we're putting multiple operations together to isolate x. So we would subtract 3 from both sides, and we get x is equal to -2. All right, so now let's put it all together. So our first example would be, so 3x plus 2, sorry for the quality, guys, is equal to 3. Okay, so we want to isolate this x term. We want to get that by itself. So to do so, we're going to subtract both sides by 2. So 3x is equal to 1. And then we're going to divide by 3. Okay, move that over a little bit. X is equal to 1/3. There we go. Okay, so, all right, so I also wanted to mention these braces. In a lot of classes, you would see something like this, set braces. What this is the solution set. So when we cover domain and range and stuff and functions, that these set braces tell us what we include, what our solutions are to the equation. What solutions are allowed in the equation and what aren't. And if you see this, essentially that means the solution set is empty, pretty much. There isn't anything that, with this equation, there isn't a solution to the equation. There isn't any value of x or any value for that variable that gives us this desired outcome or makes the statement true. Okay, so now let's do another example, okay? So what if we have 3x minus 1 is equal to 2x? Okay, so we want to get all the x's by themselves. So we're going to move 2x to the other side. So we do that by subtracting 2x from both sides. Because of the law of algebra, one of the laws of algebra, what you do to one side, you do to the other. So then we're going to add 1 to both sides, if that makes sense, to isolate x. So 3x minus 2x is 1x. And we have pretty much 0 plus 1 is 1. So 1 times x is x. So x is equal to 1. So our solution, all right, we'll check this to make sure. So our solution is 1. All right. Okay, so just one more. Sorry about that, guys. Let me get a new sheet. Sorry for the movement of the camera. Okay. Okay, so last example for the video. We have x over 5 minus 1 is equal to 3x. Okay. So we did some examples where we were pretty much just adding to both sides, and then we were just dividing out. Well, now this time we're going to isolate variables. So there's multiple ways to do this. The easiest way for me in this case, I would add 1 to both sides. So x over 5 is equal to 3x plus 1. Multiply by 5 to get rid of this denominator. Alright, so that gives us x. So this is the same as 1/5. X 1/5 x. So 5 times 1/5 is 1. By the inverse property. And then we have 5 times 3x plus 1. So by the distributive property, we're allowed to distribute this 5 to each term in the polynomial. So we have x is equal to 15x plus 5. Isolate the 15 by isolate the x variable by moving 15x to both sides. So we get negative 14x is equal to 5 divided by negative 14 on both sides. X is equal to negative 5 over 14. Or, sorry about that, guys. Didn't realize my camera was like that. Fix my camera. Okay, so that over. Alright, so pretty much about over a little bit so you guys can see the steps. So if you guys didn't catch it, so pretty much what I did was I multiplied both sides. I added 1 to both sides first. I'm sorry about that, guys. I added 1 to both sides. And then I multiplied by 5 to isolate this x over here. Apply the distributive property to make things simpler. Then we subtracted 15x from both sides to isolate the x variable, divided by 14, a negative 14, to give us a positive x. And our solution to this was x is equal to negative 15. And in solution braces too, in our set braces, sorry about that. Negative 15 over 4 is an acceptable value. So essentially what we're doing, just a recap of the video, when we're solving equations like this, what we're doing is we are undoing we're doing all sorts of different operations. So the next video we'll start functions and hopefully move on to higher levels of equations and functions and stuff. So have a great day, guys. I'll see you guys next video.